about this waveform generator using discrete components, transistor. The output is connected to the oscilloscope. This is the waveform. A waveform generator is created. Power LED. And we are using only discrete components. Into our sketch or schematic diagram, we are using two transistor NPN BC547 and with this symmetrical circuit, the same component arrangement. We have this power LED blue. Once we powering on the circuit, this power LED turns on. And then we connected our oscilloscope to the output somewhere here. This is now our oscilloscope connected to the positive and then the negative to the ground. And we have the waveform generator created. Is this an irregular waveform generated into the output of the oscilloscope. So instead of creating what we need, square wave, we just created this some irregular type of waveform. This is due to the charging and discharging of the capacitor in the circuit. So this waveform is created because of the what circuit we have is the oscillator. This is oscillator capable of turning on and off, on, off, on, off the circuit. So this is oscillator, and it behaves like this. So when this transistor is on, this one is off. When transistor is off, it looks like we don't have this transistor into the circuit. So the current flows into the oscilloscope, and the current flows all the way down to the other transistor, to the ground. And this transistor is off, so the current flows into the output, and the current flows all to the other side of the transistor, forward biasing this transistor. And then the other capacitor will discharge through the collector to the ground, and then this collector resistor to the collector to emitter to the ground, causing this to turn on. It means it acts as a short or a short switch. Act as a switch, shorting this transistor and making this other transistor to on, to off. This is off, almost open, so the current flows into the output. When this one is on, this one is off. When this one is off, this one is on. That's why we created an oscillator, causing the circuit to turn on and off. But because we're using a capacitor, we have this curved type of waveform. An irregular type waveform is created. Now we have this some sort of rectangular waveform by inserting an LED to the output of the oscilloscope. Okay, let us disconnect the LED, and we have the output regular with LED it becomes a rectangular waveform. Without LED, we have the regular waveform. With LED into the output, we have this rectangular waveform generated by the oscilloscope. Now we have made some changes to our circuit, and we have now this square waveform generated. Division 5 volts per division or division. We can see the frequency. It's 1.462 Hertz. Okay, duty cycle 46.4%, and then the other one is 53.6%. So the duty cycle is 46.546. 46.4. Then the other one, the negative or the off, is 53.6. So this is not this is a waveform. Square waveform generated by changing the circuit, by adding additional diode and resistor. With LED or load, so there is a changes in the voltage. The amplitude of the waveform without LED, an increase in the amplitude of the waveform. Now we have the new schematic diagram for our square waveform generator using transistor. It's almost the same with the original. Okay, what we need to do is to make a square wave instead of this regular waveform. That's why we have this new circuit. Although we have the same transistor, but the new components added here is the resistor and the diode. Unlike here, we don't have the resistor and the diode. Same 5 volt supply, same power LED. So the only difference is when the capacitor is charging, how did the capacitor will go into charge. So instead of charging through collector resistor, just like here, charging the capacitor to the base, biasing this transistor to turn on this transistor, all current flows into the collector emitter of this transistor. Now here it will now charge into the R6 1K, this new component, charging from R6 to C2, then to the transistor, making this transistor to turn on, and it will turn off. Since the current now flows from here to the diode and then to the output. Okay, instead of or making this transistor to cut off, entering into the cutoff region. So that's why this is on, this is off. If this is on, this is off. This is off, this is on. If this is on, this is off. Off, on. On, off. Off, on, off. That's why we call this a stable multivibrator. Some sort of an oscillator. With no permanent state. Continues to change the state from turning on, turning off, turning on. Now, when we connect the oscilloscope to the output side of the transistor, we now have this type of wave or square wave. Instead of having a curve, now we have this good looking square wave form generated into the output instead of an irregular or this curved shape type of waveform. Because of the capacitor now is discharging through the, if we make this transistor to turn on, capacitor, all the current will flow from here, then to there, then discharging this capacitor, and then current flows also into the diode, and then to the R1, C2, C2E, collector to emitter, then to the ground. It will turn on and then it will turn off. If this is off, current flows into the outside, to the output side of the circuit. So we now have an on, off, on, off. So we eliminate the curve shape of this waveform by using these new components. R6, 1K, D2, 1N, 4148 path switching diode. Then again 1K, D1, 1N, 4148. We're using capacitor of 47 microfarad, 16 volts. Same with this. And all the resistor we use 1K, 1K, 10K, 10K, 1K, 1K. And an NPN type transistor.